I don't think people understand the temple equation. Imagine a single key that could unlock many different doors. Each door leads to a room filled with understanding. Scientists have long searched for such a key in the universe. They dream of one idea that explains many mysteries. The temple equation is proposed as this kind of key. It is a new mathematical formula. Its purpose is grand and ambitious. It aims to connect ideas from mathematics and physics. These ideas often seem separate. The temple equation suggests they are deeply linked, parts of a larger unified picture of reality. The quest for a unified theory is not new. Great minds throughout history have sought it. They believed the universe operates on elegant, interconnected principles. The temple equation follows this tradition. It tries to build bridges between different fields of study. Think of it like a map. This map shows how distant lands are actually part of the same continent. The equation offers a new language. This language might help us describe the universe more completely. It attempts to show that the rules governing tiny particles and giant structures share a common source, a fundamental blueprint for existence. The temple equation is named for its aspiration. It seeks to reveal the underlying structure of the cosmos. Like an ancient temple, this structure is built from fundamental components. These components, when understood together, show a beautiful design. The equation suggests that concepts like the spin of quarks, the perfect shapes of platonic solids, and the patterns of electron placement are not isolated facts. Instead, they are expressions of a deeper mathematical harmony. This harmony also includes famous numbers like pi and the golden ratio, which appear in many natural forms. This new equation tries to speak a universal language. It is a language of patterns and relationships. It suggests that if we listen closely, we can hear the music of the spheres. This music is played by the fundamental forces and particles of nature. The temple equation is our attempt to write down the notes of this music. It is a bold step. It invites us to look at the world with fresh eyes. It encourages us to see connections where we once saw only separate phenomena. The journey to understand its full meaning is just beginning, but the prospect is truly exciting. At the heart of matter, we find tiny particles called quarks. Quarks are fundamental building blocks. They make up protons and neutrons, which are inside atoms. Quarks have a property called spin. You can think of spin like a tiny top spinning. This spin is not exactly like a toy top, but it is a basic characteristic. The temple equation considers quark spin as a vital piece of information. It suggests that the way quarks spin influences the very fabric of reality. Understanding this spin is crucial. It helps us understand how particles interact and form the matter we see around us. Another set of building blocks in the temple equation comes from geometry. These are the platonic solids. There are 5 platonic solids: the tetrahedron, cube, octahedron, dodecahedron, and icosahedron. These shapes are special. Each face is the same regular polygon. The same number of faces meet at each corner. Ancient philosophers admired their perfect symmetry. The temple equation proposes these shapes are not just mathematical curiosities. It suggests they represent fundamental structures or energy patterns at a very deep level of the universe. They might be blueprints for how energy and matter organize themselves. Then we consider electrons. Electrons are tiny particles that orbit the nucleus of an atom. They don't just fly around randomly, they arrange themselves in specific shells or energy levels. This is called electron placement. The arrangement of electrons determines how atoms interact with each other. It explains chemical bonds and the properties of different materials. The temple equation incorporates electron placement. It suggests that the rules governing where electrons can be are linked to the other fundamental elements. The stability and structure of matter depend on this precise arrangement. These 3 concepts, quark spin, platonic solids, and electron placement, seem very different. One is about tiny particle properties. One is about perfect geometric shapes. One is about how atoms are structured. The temple equation, however, suggests they are interconnected. It proposes that the spin of quarks might influence the energy fields that favor platonic solid structures. These structures, in turn, might define the stable pathways for electrons around an atom. It's like a cosmic dance where each dancer's moves affect all the others, creating a harmonious whole. Nature seems to love certain numbers and patterns. One famous pattern is the Fibonacci sequence. This sequence starts with 0 and 1. Each next number is the sum of the 2 before it: 0, 1, 1, 2, 3, 5, 8, 13, and so on. We see these numbers in many places. They appear in the arrangement of petals in a flower. They show up in the spirals of a pine cone or a seashell. The Temple equation includes Fibonacci numbers. It suggests this pattern is not just a coincidence. It hints that this sequence reflects a fundamental growth principle in the universe from the small to the large. Closely related to the Fibonacci sequence is the golden ratio. This is often represented by the Greek letter phi. Its value is approximately 1.618. If you divide a Fibonacci number by the one before it, the result gets closer and closer to pi as the numbers get larger. The golden ratio is found in art, architecture, and nature. It is considered aesthetically pleasing. The Temple equation incorporates phi. It proposes that this ratio is a fundamental constant. It might describe proportions and relationships that are essential for stability and harmony in physical systems, much like it does in beautiful designs. Another famous number is pi. Pi is the ratio of a circle's circumference to its diameter. Its value is approximately 3.14159. Pi is essential for understanding anything circular or spherical. It appears in formulas describing orbits, waves, and spheres. The Temple equation recognizes the importance of pi. It includes pi as a key component. The equation suggests that pi is more than just a geometric constant. It might be tied to the way energy curves and propagates through space, and how fundamental fields interact in spherical or cyclical patterns. These numbers, Fibonacci, phi, and pi, are like nature's signature. They appear again and again in diverse contexts. The Temple equation attempts to show why they are so common. It suggests they are not isolated mathematical curiosities. Instead, they are fundamental parameters woven into the fabric of the cosmos. They might be essential parts of the rules that govern how things grow, how they are shaped, and how they move. The equation seeks to unify them, showing they arise from the same underlying principles that also govern particles and forces, providing a mathematical language for nature's artistry. Nikola Tesla was a brilliant inventor and visionary. He had many revolutionary ideas about energy and frequency. One of his fascinating concepts was that all matter has a frequency. He believed that each object, each piece of mass, vibrates at a specific rate. This is known as the frequency of mass. The Temple equation explores this idea. It takes Tesla's insights seriously. It suggests that understanding these inherent frequencies is key to understanding matter itself. It implies that mass is not just a static property, but a dynamic, vibrational state. To make this idea more concrete, the Temple equation uses gold as a specific example. Gold is a dense, stable element. Tesla himself was interested in the properties of different materials. The equation proposes that gold has a characteristic frequency. This frequency is determined by its atomic structure and mass. By studying the frequency of gold, we might learn more about the relationship between mass and energy. The Temple equation provides a mathematical framework to calculate or predict such frequencies. It suggests that these frequencies could be harnessed or influenced. Integrating Tesla's frequency of mass into a unified equation is a bold move. It connects the properties of bulk matter to the world of waves and vibrations. The Temple equation suggests that the frequency of a mass like gold is not arbitrary. It is linked to the other fundamental constants and patterns in the equation. This includes quark spin, geometric structures, and even numbers like pi and phi. It implies a deep resonance throughout the universe. The specific vibrational signature of an element like gold might be a consequence of these more fundamental cosmic rules. This concept of mass having a frequency opens up new possibilities. If matter vibrates, then perhaps these vibrations can interact with other waves like light or sound. The Temple equation aims to describe these interactions. It could lead to new ways of understanding material properties. It might even suggest new technologies based on manipulating these resonant frequencies. Tesla dreamed of wireless energy transmission. Perhaps understanding the frequency of mass, as described by the Temple equation, could bring us closer to such revolutionary ideas, linking the tangible to the vibrational. Section 5. Electrons in motion. Understanding changing acceleration. Electrons, as we know, are fundamental particles that orbit the nucleus of an atom. They are not static. They are constantly in motion. Their movement is crucial for electricity, magnetism, and chemical reactions. The Temple equation pays close attention to how electrons move. Specifically, it focuses on their acceleration. Acceleration is the rate at which an electron's velocity changes. This means how quickly it speeds up or slows down or changes direction. Understanding electron acceleration is key to understanding how energy is transferred and transformed in many physical processes. The Temple equation goes a step further. It doesn't just look at acceleration, it considers the inacceleration. This is sometimes called jerk. Imagine you're in a car. When the car speeds up, you feel acceleration. If that speed up itself changes rapidly, for instance, if the driver suddenly presses the gas pedal much harder, you feel a jerk. The Temple equation suggests that this jerk of electrons is a significant factor. It proposes that the way an electron's acceleration changes over time is governed by the fundamental elements within the equation. How is this rate of change in acceleration represented in the Temple equation? The equation links this dynamic behavior of electrons to other core components. For example, the spin of quarks might create subtle forces that influence how electron acceleration changes. The underlying geometric frameworks, perhaps related to platonic solids, could define the pathways along which these changes are most likely to occur. Even the mathematical constants like pi and phi might play a role in defining the smoothness or abruptness of these changes in electron motion, reflecting an inherent rhythm. Understanding the rate of change in electron acceleration could have important implications. It might help explain how energy is emitted or absorbed by atoms more precisely. When electrons undergo rapid changes in their motion, they can radiate energy in the form of light or other electromagnetic waves. The Temple equation attempts to provide a more complete description of this process. By incorporating this dynamic aspect of electron behavior, the equation seeks to offer a deeper insight into the interactions between matter and energy, painting a more vivid picture of the subatomic dance. Section 6. The Symphony of Waves, Light, Sound, and the Equation. The universe is filled with waves. Light is a wave, sound is a wave, radio signals, X-rays, and even gravity, according to some theories, can be described as waves. These waves carry energy and information across vast distances. The Temple equation aims to provide a unified framework for understanding different types of waves. It suggests that light, sound, and other frequency waves are not entirely separate phenomena. Instead, they might be different expressions of the same underlying principles. These principles are described by the equation's core elements. Consider light. Light is an electromagnetic wave. It travels at an incredibly high speed. Its properties, like color, which depends on frequency, are well studied. The Temple equation proposes that the behavior of light is connected to the fundamental constants and structures it describes. For example, the way light interacts with matter, how it is absorbed or reflected, might be influenced by the electron placements and their changing accelerations. The equation suggests that pi, being related to cycles, is fundamental to describing the wave nature of light and its propagation. Now think about sound. Sound waves are vibrations that travel through a medium like air or water. They have lower frequencies than light waves. While light and sound are physically different, the Temple equation suggests a deeper connection through the concept of frequency. Tesla's idea of mass having a frequency also fits in here. The equation hints that the vibrational properties of matter, its mass frequency, can influence how sound waves are generated or how they travel through that matter. The patterns described by Fibonacci numbers might even relate to how harmonics in sound are created. The Temple equation, therefore, treats frequency as a universal concept. Whether it's the high frequency of light, the lower frequency of sound, or the proposed inherent frequency of mass, the equation seeks common mathematical descriptors. It suggests that the way energy propagates as waves is deeply tied to the geometric structures, platonic solids, and the fundamental ratios, phi, embedded in the fabric of reality. By unifying these wave phenomena, the Temple equation offers a new lens through which to view the interconnectedness of energy and its various manifestations in the cosmos. Section 7. Connecting the dots, how the Temple equation weaves it all. The true ambition of the Temple equation lies in its power to connect seemingly disparate concepts. It's not just a collection of interesting ideas. It's a proposed mathematical structure that shows how these ideas are related. Imagine a complex tapestry. The Temple equation attempts to describe the threads and the pattern of this cosmic tapestry. It suggests that quark spin, The fundamental property of matter's building blocks isn't independent of the universe's preferred shapes. The way quarks spin might set up conditions that favor certain symmetries, perhaps those embodied by the Platonic solids. These fundamental symmetries, in turn, could influence the larger scale organization of energy and matter. For instance, the allowed energy levels for electrons around an atom, their specific placement, might be a consequence of these underlying geometric and quantum rules. The Temple equation proposes a mathematical link. It suggests that the stability of atoms and molecules, which depends on electron configuration, is not an isolated fact, but is connected to deeper principles of symmetry and particle behavior. It is a cascade of influence from the very small to the atomic scale. Then come the universal numbers, Fibonacci, phi, and pi. The Temple equation doesn't just list them, it attempts to derive their significance from its core principles. Perhaps the Fibonacci sequence emerges as a natural outcome of growth processes governed by the equation's dynamics. The golden ratio, phi, might appear as a fundamental proportion that optimizes energy distribution or structural stability dictated by the interplay of forces and geometries described in the equation. Pi's role in cyclical phenomena and spherical symmetries could be shown as an inherent feature of how fields and waves behave according to the equation. Furthermore, Tesla's concept of mass frequency and the dynamics of electron acceleration are woven into this fabric. The specific frequency of an element like gold could be predicted or explained by how its constituent quarks spin, how its atoms are structured, perhaps reflecting Platonic symmetries, and how its electrons behave. The rate of change in electron acceleration, a key factor in energy emission, would also be governed by these interconnected elements. Thus, the Temple equation aims to show that light, sound, and other waves are natural consequences of this deeply unified system, all singing from the same cosmic song sheet. Section 8. Beyond our current grasp, potential scientific revolutions. If the Temple equation proves to be a valid description of reality, its implications could be truly revolutionary. Current science often operates in specialized fields. Physics has subfields like particle physics, cosmology, and condensed matter physics. Mathematics, too, has many branches. The Temple equation, by its very nature, aims to dissolve some of these boundaries. It suggests that the fundamental rules are shared. This could lead to a profound shift in how scientists approach problems. It might foster new interdisciplinary research where insights from one area rapidly accelerate progress in another. One major area of potential impact is our understanding of fundamental forces. Physics currently describes four fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces. A theory of everything that unifies these forces is a long-sought goal. While the Temple equation, as described, focuses on unifying certain mathematical and physical concepts, its framework might offer new clues for this grander unification. By linking quark properties, geometry, and energy dynamics, it could reveal underlying principles that also govern how these fundamental forces relate to each other, perhaps showing them as different facets of a single deeper interaction. The equation's insights into Tesla's frequency of mass could also open up entirely new technological frontiers. If we can truly understand and perhaps manipulate the characteristic frequencies of materials, as exemplified by gold, it could lead to breakthroughs. Imagine new methods for material science, allowing us to design substances with specific desired properties by tuning their resonant frequencies. It might also lead to new energy technologies, perhaps related to Tesla's own visions of drawing energy from the environment or transmitting it more efficiently. The possibilities, though speculative, are inspiring. Furthermore, understanding the rate of change in electron acceleration in such a fundamental way could revolutionize electronics and photonics. If we can more precisely control how electrons emit energy, we could develop more efficient light sources, faster communication systems, or even new types of quantum computing components. The Temple equation's connection between electron dynamics and fundamental constants like pi and phi might reveal optimal ways to design these technologies. It could shift our engineering from empirical design to one based on the universe's most fundamental mathematical principles, leading to unprecedented efficiency and capabilities. Section 9, the path forward, significance and future explorations. The introduction of the temple equation represents a significant moment. It is a bold hypothesis. It proposes a deep and unexpected unity among diverse aspects of mathematics and physics. Its primary significance lies in its challenge to existing paradigms. It encourages us to think differently about the building blocks of the universe. It suggests that the mathematical patterns we observe in nature are not mere coincidences. Instead, they are clues to a more profound underlying order. The very act of proposing such an equation stimulates debate, discussion, and new avenues of thought among researchers. The immediate path forward involves rigorous testing and exploration. An equation is only as good as its ability to make testable predictions or explain existing data in a new, more coherent way. Scientists will need to delve into the mathematical structure of the temple equation. They will need to see if its predictions align with experimental observations. For example, can it accurately predict properties related to quark spin or electron behavior? Can it offer new insights into the spectral lines of elements, perhaps linking them to Tesla's frequency of mass concept in a quantifiable manner? This validation process is crucial for any new scientific theory. Future explorations will also likely involve computational modeling. The temple equation, with its interconnected elements, might describe a complex system. Computers can help us explore the consequences of such an equation. We can simulate how these different factors interact. This could reveal emergent phenomena, complex behaviors that arise from simple rules. These simulations might show how Platonic symmetries could emerge from quark interactions, or how Fibonacci patterns could develop in systems governed by the equation. Such computational work can guide experimental efforts and help refine the equation itself. Ultimately, the temple equation, even if it evolves or is modified, serves as an inspiration. It embodies the human desire to understand the universe at its deepest level. It reminds us that the search for knowledge is a continuous journey. Whether this specific equation proves to be the ultimate key or a stepping stone, its pursuit pushes the boundaries of our understanding. It encourages collaboration across disciplines. It fuels the curiosity that drives scientific progress. The journey to explore its implications, to test its validity, and to learn from its structure will undoubtedly enrich our understanding of the cosmos and our place within it. Section 10, Bridging Theory and Experiment, the Golden Temple Equation in Action. The Golden Temple Equation can be expressed as follows. F underscore or equal sign K, hc squared ax nt, where F underscore or equal sign frequency associated with the mass created from light. Key equal sign proportionality constant pursuit equal sign wave function representing the quantum state of the system. H equal sign Planck's constant. M underscore or equal sign mass of gold, or another relevant particle. C equal sign speed of light, d squared x underscore e slash dt squared equal sign acceleration of electrons. A equal sign amplitude of the wave, lambda equal sign wavelength of the electromagnetic wave, nu equal sign frequency of the wave. Step-by-step explanation of how the Tesla machine proves the Golden Temple equation. Step 1. Generate high-frequency electromagnetic waves using the Tesla coil. Action. The Tesla coil generates high-voltage, high-frequency electrical discharges, producing electromagnetic waves. Relation to the equation, the frequency of these waves can be measured and related to F underscore AU in the Golden Temple equation. The energy of these waves can be linked to the mass-energy equivalence principle. Step 2. Create interactions with conductive materials, observation of photon-electron interactions, action position conductive materials, for example metal plates, near the Tesla coil to observe the effects of the generated electromagnetic waves. Expected outcome. The high-frequency electromagnetic waves can induce currents in the conductive materials, leading to observable electrical discharges, similar to photon interactions with electrons. Relation to the equation. This interaction can be interpreted as a demonstration of how energy from the electromagnetic waves can influence the behavior of electrons, contributing to the term d squared x underscore e dt squared in the equation. Step 3. Measure the wave function and frequency using basic measurement tools. Action. Use an oscilloscope or multimeter to measure the frequency and amplitude of the electrical discharges produced by the Tesla coil. Expected outcome, collect data on the frequency nu and amplitude A of the waves generated. Relation to the equation. The measured frequency can be directly compared to F underscore IU in golden temple equation, validating the relationship between frequency and the quantum state represented by piece RT. Step 4. Analyze the energy and mass relationship calculating energy from discharges. Action. Calculate the energy associated with the electrical discharges using the formula E Tauschen, where nu is the frequency of the waves. Expected outcome. Determine the energy produced by the Tesla coil and relate it to the mass-energy equivalence principle, relation to the equation. This calculation supports the term hc² in the Golden Temple equation, demonstrating how energy can be converted into mass. Step 5. Observe quantum state behavior, visualizing patterns. Action. Observe the patterns of electrical discharges and their behavior in response to the electromagnetic fields. Expected outcome. Identify how the observed patterns change with varying frequencies and amplitudes. Relation to the equation. This observation relates to the wave function PRCs RT and how it describes the quantum state of the system, reinforcing the connection between quantum mechanics and the behavior of electrons. Step 6. Validate the findings. Statistical analysis. Action. Analyze the collected data to identify correlations between the frequency, energy, and observed phenomena. Expected outcome. Determine if the experimental results align with the theoretical predictions of the Golden Temple equation, relation to the equation. If the data supports the relationships outlined in the equation, it validates the theoretical framework and demonstrates the interconnectedness of mass, energy, and quantum behavior. Conclusion. By following these steps, the Tesla-inspired machine can provide experimental evidence supporting the Golden Temple equation. The generation of high-frequency electromagnetic waves, interactions with conductive materials, measurement of wave properties, and analysis of energy and mass relationships all contribute to validating the theoretical constructs outlined in the equation. This approach emphasizes the principles of resonance and electromagnetic phenomena, reflecting the innovative spirit of Nikola Tesla while exploring fundamental concepts in physics. Section 10. Bridging Theory and Experiment. The Next Frontier. As we stand on the precipice of understanding, the Temple equation offers a tantalizing glimpse into the interconnected fabric of the universe. But how do we bridge the gap between the theoretical framework and experimental validation? To begin, we revisit Einstein's mass-energy equivalence, E@mc². This foundational principle suggests that energy can be converted into mass. High-energy photons, such as those from powerful lasers or particle accelerators, serve as our energy input. When these photons collide with electrons at sufficient energy levels, they can create new particles, exemplified by the phenomenon of pair production. Next, we delve into the quantum realm, where the behavior of particles like electrons and their interactions with photons play a crucial role. Utilizing advanced quantum observation techniques, we can monitor these interactions, influencing the state of electrons through wave function collapse. This quantum observation is key in determining the outcomes of photon-electron interactions. Here, the Golden Temple equation comes into play. By integrating various physical concepts such as wave functions, frequency, and material properties, the equation provides a framework to explore the relationship between light and mass. Specifically, it relates the frequency of photons to the mass produced, proposing a theoretical pathway for creating mass from light. Imagine using this equation to manipulate photon frequency and energy, observing the resulting electron interactions, and potentially creating mass. This speculative yet logical approach underscores the interconnectedness of energy, mass, and quantum behavior. While this framework remains theoretical, it paves the way for experimental validation. Advanced technologies will be required to generate high-energy photons and measure particle interactions with precision. Such experiments could provide the evidence needed to confirm or refine the Temple equation's predictions. As we embark on this journey, the Temple equation inspires us to push the boundaries of scientific inquiry. It challenges us to think differently, to explore new avenues, and to integrate diverse fields of study. Whether it leads to groundbreaking discoveries or serves as a stepping stone, the pursuit of this knowledge enriches our understanding of the cosmos and our place within it. The next frontier awaits, where theory meets experiment and the mysteries of the universe begin to unravel. Join us as we continue this quest for knowledge, driven by curiosity, collaboration, and the unyielding human spirit. Welcome to the final segment of our journey, where theory meets imagination. In this chapter, we delve into the hypothetical process of building the Golden Temple, a structure that embodies the principles of the Golden Temple equation. While this remains a theoretical endeavor, it offers a fascinating glimpse into the future of scientific possibilities. First, let's revisit the foundational concept of mass energy equivalence, R times c squared. This principle suggests that energy can be transformed into mass. Imagine harnessing high-energy photons, perhaps from powerful lasers, to initiate this transformation. When these photons collide with electrons at sufficient energy levels, they could create new particles, a phenomenon known as pair production. To build the Golden Temple, we would need an advanced high-energy laser setup capable of producing photons with energies high enough to significantly interact with matter. These photons, emitted at precise frequencies, would be directed towards a carefully chosen target material such as lead or mercury, which could theoretically be transmuted into gold through nuclear reactions. The Golden Temple equation comes into play here, providing a framework to understand these interactions. By integrating various physical concepts like wave functions, frequency, and material properties, the equation proposes a pathway for creating mass from light. It relates the frequency of photons to the mass produced, suggesting a method to manipulate photon energy and observe the resulting interactions. In practice, this would involve a series of steps. 1. Utilizing a high-energy laser to emit photons at the required frequency. 1. Targeting a material that can undergo nuclear reactions to form gold. 1. Inducing these reactions through precise photon interactions. 1. Observing and measuring the mass created, validating the equation's predictions. This speculative approach underscores the interconnectedness of energy, mass, and quantum behavior. While it remains beyond current scientific capabilities, it paves the way for future explorations. As we conclude this theoretical journey, remember that the Golden Temple equation is more than a mathematical formula. It symbolizes the quest for knowledge, the integration of diverse scientific fields, and the endless possibilities that lie ahead. Whether it leads to groundbreaking discoveries or serves as a stepping stone, the pursuit of this knowledge enriches our understanding of the cosmos and our place within it. Thank you for joining us on this exploration. The future awaits where theory and imagination converge to unlock the mysteries of the universe. Welcome to the concluding chapter of our journey, where we explore how to test the Golden Temple equation and the future implications of this theoretical framework. In this segment, we'll delve into how we might one day test the Golden Temple equation and what it could mean for the future of science and technology. The concept of transforming light into gold through the use of lasers, guided by the principles of the Golden Temple equation, is a captivating theoretical exploration. While the actual process of creating gold from light is not feasible with current technology, we can discuss how energy conversion, mass energy equivalence, and photon interactions could theoretically relate to such a process. First, let's revisit mass energy equivalence. According to Einstein's equation E = mc squared, energy can be converted into mass. This principle is foundational in understanding how energy from photons, essentially packets of light, could theoretically create mass, in this case gold. The energy associated with high-frequency photons can be substantial enough to influence atomic structures. Next, consider photon interactions. High-energy photons, such as those produced by lasers, can interact with matter in various ways. In high-energy physics, processes like pair production can occur, where energy from photons creates particle-antiparticle pairs. If we could manipulate these interactions effectively, we might explore the creation of heavier elements. The Golden Temple equation provides a framework for understanding the relationships between frequency, wave functions, and mass energy conversion. The equation can be expressed as F underscore R equals sign K hc squared ax nt. Here, F underscore R represents the frequency associated with the mass created from light, and M underscore O would represent the mass of gold. To theoretically create gold using lasers, we would need 1. A high-energy laser setup. Utilize a high-energy laser capable of producing photons with sufficient energy to induce significant interactions with matter. The laser must emit photons with energies high enough to exceed the binding energy of electrons in the target material. 2. A target material. Introduce a target material that contains lighter elements such as lead or mercury that could theoretically be transformed into gold through nuclear reactions. The laser would need to provide enough energy to overcome the nuclear binding energy of the target atoms. 3. Inducing nuclear reactions. The high-energy photons from the laser could theoretically induce nuclear reactions in the target material, potentially leading to the formation of gold. This could involve processes such as neutron capture or other nuclear transmutation methods. 1. Energy conversion and mass creation. If the conditions are right, the energy from the laser could theoretically convert into mass, resulting in the formation of gold atoms from the lighter elements in the target material. While the theoretical framework for turning light into gold using lasers is intriguing, it remains speculative and beyond current scientific capabilities. However, the principles of mass energy equivalence, photon interactions, and the Golden Temple equation provide a conceptual basis for understanding how energy could potentially be transformed into mass. This exploration serves as a creative intersection of physics, metaphysics, and the mysteries of the universe, inviting further inquiry into the nature of energy, matter, and consciousness. As we continue to push the boundaries of scientific knowledge, who knows what future discoveries await? Thank you for joining us on this fascinating journey through the realms of theoretical physics and beyond. Stay curious, keep exploring, and remember, the universe is full of endless possibilities. As we delve deeper into the theoretical aspects and scientific possibilities of the Golden Temple equation, it's essential to take a moment to reflect on the broader philosophical implications of this groundbreaking concept. The Golden Temple equation doesn't just propose a new framework for understanding the physical world, it also challenges our perception of reality, consciousness, and the interconnectedness of all things. At its core, the equation suggests a harmonious relationship between fundamental forces, particles, and energies that shape our universe. This harmony resonates with ancient philosophical ideas about the unity of existence, where everything is interconnected in a grand cosmic dance. Consider the notion of transforming light into gold. While scientifically speculative, it echoes alchemical traditions that sought to transmute base materials into noble ones, symbolizing a journey of spiritual and intellectual enlightenment. The Golden Temple equation, in this sense, can be seen as a modern alchemical formula, not just for material transformation, but for elevating our understanding of the universe. Moreover, the equation invites us to reconsider the boundaries between science and metaphysics. Are the mysteries of consciousness and the nature of reality merely scientific puzzles to be solved, or are they deeper questions that require a synthesis of scientific inquiry and philosophical contemplation? As we stand on the brink of potential scientific revolutions, the Golden Temple equation reminds us that the pursuit of knowledge is not just about technological advancements, but also about the profound quest to understand our place in the cosmos. In exploring the Golden Temple equation, we are not just unlocking new scientific possibilities, we are also engaging in a timeless dialogue about the nature of existence, the limits of human understanding, and the infinite potential of the human spirit. Thank you for joining us on this intellectual and philosophical journey. As we continue to explore the mysteries of the universe, let us remain curious, open-minded, and ever inspired by the endless possibilities that lie ahead. Stay tuned for more explorations into the unknown, and remember, the quest for knowledge is a journey without end.